hope you all are good. Welcome to World of Maths. This video we will continue the second chapter, polynomials. In our previous video we have learned how to find the zeros of a polynomial. So here it is a geometrical representation of the zeros of a polynomial. We will see how to represent the zeros of a polynomial in a graph. Let's start. Geometrical meaning of zeros of a polynomial. So students, what are zeros of polynomial? Zeros of polynomial are the value of x which makes the polynomial equal to 0. Now we are representing these values in a graph. So the zeros of a polynomial are the points where its graph cuts the x-axis. So by displaying the x values on the x-axis and the associated polynomial values on the y-axis, we can draw a graph of a polynomial p of x. We know in a graph there is x-axis and y-axis. So we will display the x values on the x-axis and the associated polynomial values on the y-axis. Then we will get the graph of the polynomial p of x on xy coordinate axis. So now let's see how the zeros of a linear polynomial will look like. Geometrical meaning of zeros of a linear polynomial. So consider a linear polynomial y is equal to 2x plus 3. Why this is called a linear polynomial? Because the highest power of x is 1. So 2x plus 1 plus 3 is a linear polynomial. So I have made a table here to draw the polynomial on a graph. So when we replace the value of x in 2x plus 3, when we replace the value of x to minus 2, we will get y is equal to 2x plus 3, value is minus 1. So we are replacing value of x in 2x plus 3 to minus 2. So that will be 2 multiplied by minus 2 plus 3 will give you 2 in minus 2 is minus 4 plus 3 will give you minus 1. In the similar way, we have replaced x value from minus 2 to 2, and we have here we can see the value of y when we replace the value of x. So it is the value of x is minus 2, the y became minus 1, and from minus 2 to 2 we have find the value of y of that particular polynomial. Now let's represent this on a graph. In this picture here we can say these are the first one is minus 2. When the value of minus 2, it is minus 1. So coordinates of x is minus 2 and y is minus 1. So this is the first point which I have marked here. So this is the first point, and second one is minus 1 and 1, which is this. This is the second point, and the third point is 0 and 3, which is marked on the y-axis, and we have the fourth one 1 and 5, which is here, and the last one which is 2 and 7, which is here. When we connect these points, we get a straight line. So that is something important for a linear polynomial. When we connect the graph of a linear polynomial, it forms a straight line. Always it forms a straight line. Now let's see the point which the graph cuts the x-axis, exactly here. So the point which cuts the x-axis is in between minus 2 and minus 1, which is, we can say, minus 1.5. This point is minus 1.5. In fractional form we can say it as minus 3 by 2. So in a linear polynomial, the graph of a linear polynomial cuts the x-axis at one point, exactly one point, and that is the zeros of that polynomial. So here the zeros of this polynomial is minus 3 by 2. So when x value x equal to minus 3 by 2, this polynomial will give you equal to 0. So when we replace the value of x here in this polynomial to minus 3 by 2, this equation will turns to 0. So in that way we can say the zeros of this linear polynomial is minus 3 by 2. And minus 3 by 2 is the fractional form of 1.5. We can see this line is exactly intersecting at this one point between minus 1 and minus 2, which is minus 1.5, and the fractional form of minus 1.5 is minus 3 by 2. In fact, we can say for a linear polynomial ax plus b where a not equal to 0, the graph of y is equal to ax plus b is a straight line. So, a graph of a linear polynomial is always a straight line and it intersects the x-axis at exactly one point. It intersects the x-axis at exactly one point, which is it is namely minus b by a minus b by a. So, if it is ax plus b, we can replace this polynomial as 2x plus 3. 2x plus 3. This is minus ax plus b in the form of ax plus b. The zeros of this polynomial is minus b by a, which is minus b is minus 3 by 2. So, the zeros of this polynomial is minus 3 by 2. Also, this linear polynomial has only one zero. We have learned the linear polynomial, how many zeros does a linear polynomial will have? It will always have only one zero, and it's the x coordinate of that point where the graph of y is equal to ax plus b intersects the x-axis. Once again, the linear polynomial will have only one zeros, and that zeros is the point at which the graph of this polynomial cuts the x-axis. Now, let's see the geometrical meaning of 0 in a quadratic polynomial. So, consider the quadratic equation y is equal to x squared minus 3x plus 4. This is a quadratic equation. We can see the power of x is, highest power of x is here too. So, hence it is a quadratic equation. Similarly, we have find the coordinates formed for this polynomial x squared minus 3x plus minus 4 by replacing the value of x from minus 2 to 5. So, I have made a table here replacing the value of x in this polynomial. We will get y is equal to, replacing the value of x to minus 2, y will be equal to 6, and if we replace by minus 1, 0, and similarly until 5 I have replaced the value of x and find the x-axis y value, which is shown in the table here. So, we have the coordinates formed for this polynomial. Now, let's see how the graph looks like when we represent this in a graph. Now, the first point, when we replace the value of x to minus 2, we got it as by the y value to 6. So, while we mark that here, I have already marked it here. So, it is the first point is placed here, minus 2 and 6. The second point is when the value of x is minus 1, y is equal to 0, which is on the x-axis. So, here it cuts the x-axis, and if the value of x is 0, the value of y is minus 4. So, it is marked somewhere here 0 and minus 4, and when value of x is 1, the value of y is minus 6, which is marked here. Value of x is 2, then it is 2 and minus 6. The next one is 3 and minus 4, and then we have 4 and 0, which again cutting the x-axis, and finally we have 5 and 6, which is marked over here. So, we have connected this all points, and you can see the shape formed. It is a curve. These curves are called parabolas. What we will call? These are called parabola. And we can see the zeros of this polynomial where it has cut the x-axis in two different points. So, the zeros of polynomial are, one is minus 1 and other one is 4. So, zeros of this polynomial is minus 1 and 4, and we can say that it has been cut the x-axis at two different points. So, again we can say the shape formed for a quadratic polynomial is a parabola, are called as parabolas. Now, since it is a quadratic polynomial, it can have at most two zeros. It can have one zeros and it can have no zeros. For all these cases, the graph will be different. So, let's see if the case 1, the graph cuts the x-axis at two distinct points. So, here in first graph we can see the x-axis is cut at two different points. Even in the second figure also we can see the x-axis has cut on two different points. In this case, the quadratic polynomial has two zeros. So the zeros of the polynomial are figured when it cuts the x-axis. So in this graph it has cut at 2 times, so it has two zeros, and even here also it has cut the x-axis at 2 different points, so it has two zeros. Case number 2, when the graph cuts the x-axis at exactly 1 point. So here we can see, I have already marked here, so the graph is cut here, and in the second figure it's cut here. It's just in the 1 point. We can see in x-axis it has cut only at 1 point. In this case, this quadratic polynomial has only one zero. So number of zeros is directly connected to the how many times that graph intersects the x-axis. So if it has cut at one time, so it has only one zero. And the last case is when the graph does not cut x-axis at any point. So here we can see this graph is not at all cut x-axis at any point. In this case, we can say that quadratic polynomial has no zero in. So when the graph is not even touching the x-axis, not cutting the x-axis, we can say it has no zero. So let's summarize. The graph of a linear polynomial is a straight line. We have seen previously it cuts the x-axis at exactly 1 point, and a linear polynomial has one zero. So it cuts the x-axis at exactly 1 point. And the graph of a quadratic polynomial is a parabola. The curve, it looks like a curve. It is called as parabola, and it can cut the x-axis at 0, 1 or 2. So it can have at most 2 points. So a quadratic polynomial can have at most two zeros. Similarly, it can cut the x-axis at most 2 points, or it can cut 1 point, or it can have zero cut. So it depends upon the zeros of that polynomial, and a quadratic polynomial has at most two zeros. And the graph of a cubic polynomial can cut the x-axis at 1, 2 or 3 points. A cubic polynomial has at most 3 zeros. So we have learned the relationship between the polynomials, the degree of the polynomial and the zeros. So according to the degree, n degree, if the polynomial with n degree can have at most n number of zeros. A polynomial with n degree can have at most n number of zeros, and at how many number of zeros the graph will intersect the x-axis. Let's see few more examples. Look at the graphs given below. Each one is a graph for y is equal to polynomial p of x, where p of x is a polynomial. Looking at the graph, let's find the number of zeros. In the first figure, we can see the graph has cut the x-axis exactly 1 point. So this will have only 1 0. It has only 1 0. And here we can say this graph cuts the x-axis at two different points, and it will have two zeros. The quadratic polynomial will have two zeros. Here again, the third figure, we can say it's cutting 1, 2 at 3 places. So this has 3 zeros. So first one will have only 1 0, and this one has 2 zeros. It has 3 zeros. And here we can say it has cut the straight, and it's also a straight line. So this can be a linear polynomial, and it has only 1 0. Here also again it cuts only in the x-axis. Since the shape is a parabola, it will be a quadratic polynomial, and it has only 1 0. Here we can say 1, 2, 3 and 4. So this polynomial has cut the x-axis at 4 points. So it can be a polynomial with a higher than degree, can be a 4 degree polynomial. So I hope you understand how to find the zeros of a polynomial looking into their graph. Let's do exercise number 2.1 from textbook. So the graphs of y is equal to polynomial of x are given below. For some polynomials p of x, find the number of zeros in each case. Looking into the first figure, we can see it has not cut on the x-axis. So there is no zeros for this polynomial. So the number of zeros for first graph is 0. So it has no zeros. Here we can say it has cut the x-axis at 1 point. It's cutting it here, so it's just have 1 zeros. And here at 1, 2 and 3 points, so it has 3 zeros. Here it is cutting the x-axis but 1 and 2, so it is 2 zeros. And the next one 1, 2, 3 and 4, so it has 4 zeros. Again 1, 2 and 3, so it has 3 zeros. So I hope you are clear on how to represent a zeros of polynomial on a graph and seeing the graph to find the number of zeros of that polynomial. So students, I hope you enjoyed the video very well and now you are clear on the topics of zeros of polynomial, how to represent the zeros on a graph and seeing the graph to know how many number of zeros it has. Please like, share and subscribe and comment if you need more videos on the same topic. Thank you for watching.